Every country in the world produces organic waste. Now imagine that this waste can be converted into material that absorbs carbon dioxide. Awesome, right? This is biochar, a material that comes from biomass. And in simple words, biomass is all of us. The process in which biochar is formed can have different results, as the type of biomass used can vary, which also impacts its chemical composition. These variations in composition lead to different uses, such as fertilizers in agriculture and compounds for construction. Biochar even looks like a simple piece of charcoal, but it is much more than that. It has a unique CO2 encapsulation capacity that can be beneficial in many areas. The main component of biochar is carbon, which, instead of going to the atmosphere, is encapsulated in the form of biochar to prevent the formation of carbon-based polluting gases. The basis in the chemical structure of organic matter is carbon, and this fulfills a natural cycle. However, biochar interrupts that cycle and retains carbons for much longer, a minimum of 10,000 years. As a result, it prevents carbon from returning to the atmosphere. On average, between 70 and 90% of the weight of biochar is carbon that will be retained. In addition, since biochar is manufactured from biomass and organic waste, it could be a very effective way to recycle these, as we can see in the graph. 46% of the total global garbage is of organic matter. In Ecuador, an average of 61.41% of total waste is organic, representing a great opportunity to create biochar. We're about to tell you about the inclusion of biochar in concrete, since depending on the material used, the original size of these biochar particles will vary from 6 to 50 millimeters. These sizes can be reduced and therefore included in concrete mixes.
So, can we use biochar in concrete and not affect its properties? The answer is yes. We can use biochar in two ways, as a cementitious material or as a filler. However, for each way of use, there are specific biochars. In the case of biochar as a cementitious material, it must have an optimal content of silicon oxide to be a pozzolanic material. Good candidates for this use are, for example, rice husk and bagasse. When using biochar as a filler, there aren't any specific standards to comply with, so an example of this type of biochar would be from wood waste. But is all of this safe? As a matter of fact, it is. We can use biochar and not affect the properties of concrete. We suggest a maximum use of 5% biochar. With this percentage, we not only maintain the physical properties, but we are also improving and adding new features to our concrete, such as the reduction of thermal conductivity and having a greater thermal resistance than normal concrete. We would also improve concrete as an acoustically absorbing material, improving from 0.25 to 0.45 on the NRC. But what about compression strength? Using biochar as a filler, we have an increase of 3% compared to normal concrete, and as a cementitious material, this property increases up to 36%. And as this were not enough, according to studies, we can save a whole $1 for every 0.25% of addition of biochar in our mixtures.
We know there is a lot of research on biochar in concrete, but its application is still limited. So, how can we make each country accept the idea and develop it? Our group proposes to carry out a future competition focused on the use of biochar in concrete, with the objective of contributing and educating the future generation of civil engineers in the sustainable development of concrete. This student competition aims to promote the idea of the use of biochar in the designs of concrete mixtures of typical use. And how would this competition work? Teams are asked to develop an innovative concrete mix design that contains as much biochar as possible, while maintaining or improving its properties, as compared to 4,000 psi standard concrete mix. To achieve this goal, the teams are encouraged to seek out and use local biomass resources to generate the biochar in one of the two categories of the contest. Category A consists of using biochar as a filler of maximum 10% by weight. Participants need to consider that this may reduce its strength. Category B consists of using biochar as an SCM with the objective of reducing the use of cement itself and increasing the production of biochar as well, therefore sequestrating CO2 in the process. The materials that will be used in both categories need to fulfill ASTM standards: cement, water, additive, and aggregates. What are the requirements to participate? For both categories, the teams must make 3 test specimens, 10 per 20 centimeters, cured for a minimum of 7 days. A cylinder compressive strength test shall be performed in accordance to ASTM C39. The results obtained will be evaluated by a committee of the ACI. And how will the committee evaluate participants? The qualification parameters for both categories will be: 1. Globalization impact, 40%. The participants must use locally sourced biochar. Biochar needs to be globalized so people understand the material and the benefits of its use in concrete mixtures. This will lead to more research and local applications. 2. Environmental impact, 40%. This will be evaluated by the percentage of the equivalent CO2 encapsulated. This percentage can be obtained with a database where there is amount of equivalent CO2 depending on the type of biomass. 3. Economic impact, 20%. The economic impact will be evaluated by the ratio of the compressive strength of the specimens and the total cost of the mix. If the cost is lower and the compressive strength is higher compared to regular concrete, people will tend to use biochar and reduce the cost of mixtures. Finally, at this point you're probably wondering why we're talking about all of this. If not, let us tell you anyways. We're all aware of the great importance the concrete industry has worldwide. In fact, concrete is the most famous construction material there is. The downside? It is also one of the most polluting materials. The cement industry represents 8% of the global CO2 emissions, and world powers know that this issue must be controlled somehow. An example, the European Union climate policy establishes that the cement industry is obliged to reduce their emissions to reach net zero emissions by the year 2050. Just by using 1% of biochar by weight of cementitious materials in concrete, we will be able to retain 0.5 gigatons of CO2 each year, rather than letting it go back to the atmosphere. This alone would represent close to 20% of the total yearly emissions of CO2 caused by the cement industry. We would also be reducing the use of cement in 1% for concrete mixtures, decreasing the amount of CO2 the industry emits simply by lowering cement production. But will this change the impact of the concrete industry worldwide? Well, yeah, we can ensure the development of biochar concrete mixtures can help the industry reach different SDGs, such as industry innovation, sustainable cities, and positive climate action. Biochar production will even bring new opportunities for farmers and small producers in developing countries like ours, since any kind of biofuel operation will contribute to the social and economic development of local, rural, and indigenous people and communities. Our proposal with this competition of biochar concrete is to take the first step towards popularizing biochar, specifying concrete mixtures that include it and boosting its production worldwide.